Alright guys, welcome to this video on Euler's method. So this is a pretty exciting little topic for us. This is something I can guarantee is going to be on the AP Calculus test this year. So let me tell you about this guy Euler first off. So I know his name is pronounced like it might be pronounced Euler, that's how it's spelled, but it is actually pronounced like I'm doing it, Euler. Like that's how you want to pronounce it. Euler's an absolute genius mathematician, one of the all-time greats. And when you see the letter E that we use all the time, of course, E stands for Euler. He's kind of the guy who discovered it. All right, so here's what Euler's method lets us do. Euler's method lets us approximate a solution. So we've already talked about how when you look at a differential equation like this, like x squared minus y, we have x's and y's added, you can't separate. But Euler came up with a way that you can approximate a solution at a point. And here's how Euler's method is going to work. And we're going to get to a formula, and I'm going to show you where that formula comes from. When we think about slope, we think about slope as being a change in y over a change in x, a rise divided by a run. Now, we can also think about that. Of course, we could just multiply the delta x to the other side. So we could say delta y is the slope times the delta x. And in more calculus-y terms, instead of a slope, we could think of the change in y as being dy dx times the change in x. And this is the key formula for Euler's method that you want to be doing and thinking about. Okay, so let's go back and let's do an example problem here using this differential equation. So suppose I tell you dy dx equals x squared minus y. And I am going to ask you if y of 1 is equal to 0, so at the point 1 comma 0, estimate y of 2 using Euler's method and 2 steps of equal size. So Euler's method and 2 steps of equal size. So each step is like basically similar to a tangent line. So what we're kind of doing is we're saying, okay, we're in this slope field. The slope field is pointing in this direction. Let's take a step in that direction. Now which way is the slope field direction going? Okay, the slope field is pointing that way. So let's take a step in that direction. Now the slope field is pointing in another direction. So let's take a step in that direction. That's how you're going about this. The way that I like to organize my work, and you can do it this way or whatever way makes sense for you, is I make a table. And I'm going to label this table as you should on the AP test with 3 parts. So we're going to find the x and the y. At each point, we're going to find the slope, dy dx. And then I'm going to find this highlighted formula, change in y, which is dy dx times the change in x. Okay, so what we're going to do, at the top of the table, we're going to have our starting point. Our starting point is the one that was given, that initial condition. And the initial condition that was given to us, of course, was 1 comma 0. Okay, and they're telling me I'm going to end at y of 2. So that's my end condition, is to get to 2 comma something. And that's my goal. My goal is to figure out the y value at 2 and what that's going to be. Let's not put a question. Let's just leave it blank. Okay. Now, they told me that we're taking 2 steps in this problem. So what that means is if we're taking 2 steps, I'm going to go to an intermediary step and then take a second step to 2. Now, hopefully you look at this and you agree the intermediate step is 3/2. Okay, now I'm just filling in the x's here. So basically what I'm going to do is in each step, I'm going to find dy dx. And of course, to find dy dx there, I'm just using the differential equation. And then I'm going to calculate the change in y, and then I'm going to add that change in y to the old y value. Okay, so let's take a look at this. dy dx, so I'm using this formula, dy dx equals x squared minus y, so I'm just going to plug in the point 1 comma 0. So when I plug in the point there, at that point, my dy dx is equal to 1 squared minus 0, which is 1. So now that I've done that, I found the dy dx. Now I'm going to calculate the change in y. Okay, and to do that, I need the change in x. Well, that change in x is what's called the step size. It's how much does x change from one point to the next point. And we can see here pretty clearly that that's just 1/2. One tip I'll give you to make these problems easier, I will always recommend using fractions instead of decimals. If you have a calculator, you can use decimals, but if you're doing this by hand, fractions are going to make your life just so much easier. Okay, so what that means is my change in y is equal to dy dx, which I just calculated as 1, times the change in x, which is 1/2. So that's 1/2. Okay. So this is a change in y. It's not the new y, in this case it is, but I need to add that delta y to the old y. So I'm going to take this 1/2, and I'm going to add a 1/2 to the old y. So I start at 1, 0, I add 0 plus a half, so now I'm at the point 3/2, 1/2. Okay, so now when I do this, I'll calculate my dy dx again. So again, I'm going to take this new point. So I have this new value of xy, and I'm going to plug that new value in here. Okay, so that's x squared minus y. So that's going to be 3/2 squared minus 1/2. So that's 9/4 minus 2/4, that's 7/4. Okay, so my change in y will be 7/4 times, and the delta x is always going to be the same. We're always going to take equal steps in here, so it'll be identical from step to step, 1/2, which is 7/8. Okay, so again, I have that delta y, so I'm going to add this to the previous y value I had, the old y. So I'm going to do this 1/2, and I'm going to add 7/8. So that tells me that that was a goal. Okay, that tells me my y of 2 is approximately 1/2 plus 7/8. Okay, and that's my final answer. I'm done with the problem. So you're only going to do this when they say use Euler's method, but this is the step you're going to do. You're going to make a table, and xy, you're going to calculate the slope, that dy dx, calculate that change in y, and then just add that change in y to the old y value in a sense to get your goal. Okay, let's do a couple more examples so we can see this. And this is my thought of how I organize. If something else makes more sense to you, feel free to do that. Okay, so now I'm going to set up a slightly different one. So I'm going to tell you that dy dx is equal to x minus y, and I'm going to tell you that y of 1 is equal to 0, and I'm going to ask you to estimate y of 2 using 3 steps of equal size. Now, most of the time in the AP test, it'll be 2-step, but you never know. It could be 1 step, which is honestly just a tangent line. But so when we're doing this with 3 steps of equal size, again, this is my start right here. I'm starting at 1, 0. I'm ending at 2. So I'm going to set up my table xy. I'm going to calculate my dy dx, which might be helpful just to rewrite. And then I'll find my change in y, which is dy dx times change in x. And then, of course, I'll just add that on to the old y value. Okay. So what do we have? Well, again, we're starting at 1, 0, and I'm taking 1 step, 2 step, and a 3rd step. So I'm trying to end up here at 2, something. Now I have to get a distance of 1 in 3 steps. So my distance over my number of steps will tell me the step size there. So I'm taking I'm moving a distance of 1 in 3 steps. So I'm going to go up by 1/3 each time. So 4/3 and 5/3. And bear with me because this is going to get a little bit gross here. Okay. So with that in mind, how do I calculate this? Well, let's see. At each one, I'll just plug into this differential equation. So my dy, and hopefully you see, you kind of just go through the same steps and repeat. So this is 1 minus 0, which is 1. So that means my change in y is 1 times 1/3. So I'm going to add a 1/3. So this works out to be 1/3. Okay, and now that was a step, right? I calculate the slope, I calculate the change in y, and I add, and now I just repeat 2 more times. And you'll see, of course, that I am a magnificent person, so I made this really easy for you. The fractions don't propagate in a bad way at all, because the slope here is just 1. So dy dx is 1 times 1/3, which is still 1/3, so I'll add a 1/3, and now I'm at 2/3. Okay, don't expect them to be this nice on your homework, but anyway. So my change in y here would be 5/3 minus 2/3, which again is 1. So my change in y is 1 times 1/3, so again, I'll add a 1/3. So the approximation I get here is 1. So my answer in this case is that y of 2 is approximately equal to 1. Okay, so again, we're following the same steps. Find the slope, calculate the change in y, add it to the old y. It's something that hopefully is obvious, but the more steps you use, the more accurate your answer is going to be. Obviously, the more steps you have, the math gets uglier and uglier, but it is what it is. Okay, so let's look at another example here. This one is going to be a little bit different. So in this case, I'm going to tell you, suppose I'm going to give you the dy dx. I'm going to be nice. It's just in terms of x here, just 2x. And suppose I tell you that y of 0 equals -2. So at the point 0, -2. I'm going to ask you to estimate y of -1 using Euler's method. Again, and don't ever use this unless the problem literally tells you to use Euler's method. Using 2 steps of equal size. Okay, so let's see. We're going to begin here. Again, make the table to kind of help you. Make sure you label the table. And then your change in y is dy dx times change in x. Okay, so let's see. We start at 0, negative 2. And my goal is to take 2 steps and get to negative 1, something. Now, here's a thought. Aren't my x's decreasing? My x's are getting smaller. So my x's are getting smaller. And hopefully you look at this and you're like, oh, yeah, obviously the middle one is negative 1/2. But because the x's are getting smaller, that means my change in x is actually negative 1/2. So be careful with the sign. That x is decreasing. Okay. So keep that in mind and maybe even write it up here so you don't forget. But because that x is getting smaller, we do have a negative step size right there. Okay. All right. So let's go ahead and calculate these. So my first one, dy dx, is 2x. So now, again, I'm a very nice person. That's worked out to be 0. So your change in y then is 0 times negative 1/2, which of course is 0. Now again, we're not replacing it. We need to add the 0 to the old y. Negative 2 plus 0 means I remain at y equals negative 2. Okay, now I took a step. Now I need to recalculate the slope. So here my change in y is 2 times negative 1/2. So that just worked out to be negative 1. Okay, so my change in y, let's redo this. And again, hopefully you're following through and doing this on your own and kind of carrying through the algebra yourself. That's the goal here. My dy dx here is negative 1 times negative 1/2. So that just works out to be positive 1/2. Okay, so I will add 1/2 here, so I'll get to negative 3/2. Okay, so there's my approximation. Y of negative 1 is approximately negative 3/2. Okay, so that's how Euler's method works. That's how you solve these problems. Just beware here of the negative step size. All right, thanks for watching. I'll see you guys soon.